I think this symbol here is new, right? That there?
I've seen it before on
So I'm going to jump down to my second line where I just put that thing in red. And I'm going to say that that's called a radical sign. So that thing there is a radical sign. And often you'll hear it referred to as a radical sign. More often, they're going to call it like a square root or something like that. So if I wanted to say this thing here below that, if I wanted to say this, I would call that square root of 25. This thing here would be square root of 49. Fair enough? So what it means, though, so this line up above in my upper left, when you have that square root of a number, what that means is it means what squared equals that number. So in other words, what I'm trying to say is, maybe pause, let you write that down. So what I'm trying to say with this here is when I see square root of 25, in my brain I want to know that that's saying, well, what number times itself, what number squared gives me that 25? And you would say 5. So square root of 25 is going to be 5. And I'm just going to write the little justification after it, but it's because 5 squared equals 25. Or 5 to the second power, is that totally new or not? That's not, okay. But if you're looking at that and it's a little bit weird, 5 squared is just saying 5 times 5 equals that 25. Good? So the square root of 49 has to equal 7. And that's because, most of you, it's probably not worth writing, but it's because 7 squared equals 49. Good? Now, sometimes those work out nicely like that, and you can do them in your head like most of you pretty much did. But your calculator has a button. I'm guessing most of your calculators have an x squared button. It's over on the left-hand side. If you look up above that, it'll probably be in like a yellow or a light blue. You have a square root symbol up above it. Some of you don't have that. Some of you instead have a button probably above the numbers that say square root of x. Oops. Square root of x. So, okay. But here's what you need to be able to do. If you have this type of button, you have an x squared with a little radical sign up above it. To type in square root of 49, you do your second key. And that'll tell you it's going to, whatever you hit next, it's going to be the symbol above the key. Second, and then if you hit that x squared button, it'll pick the square root. Then you can do your 49 equals. So some of you typing in this key sequence here will give you the 7. For other people, if you have more this type of button, that square root of x button, for you, you type in the 49 first, and then you just type in that square root of x button, and it'll get you to the 7. So figure out how your calculator works. Anybody need help? All right, so now that everybody can do that, I want to talk about a perfect square. And I'm going to have to squeeze mine in a little bit. You probably don't have all this stuff in the blue over on the side. But a perfect square. The common mistake people make is they say a perfect square is a square that looks pretty, or a square where all the sides are the same. Like this is related to, but a perfect square, I want you to train your brain that we're not talking about a square object. We're not talking geometry right now. Fair enough? A perfect square equals a whole number squared. So a perfect square equals a whole number squared. And when we're talking about a whole number, the key is just that there's no decimals. So like 2 is a whole number. 17 is a whole number. 4 is a whole number. 4.5 is not. Good?
Great.
So if a perfect square is going to be a whole number squared, 1 squared, 1 times 1 is 1. So 1 has to be a perfect square. 2 squared, or 2 times 2 is 4. 3 squared,
9.
9. That says 3 times 3 is 9. So ... You could do 49 because that's 7 times 7. It's 7 squared. But a perfect square is going to be a number that's a whole number with no decimals squared. Okay on those?
Okay?
If you wanted to take the geometry approach, and maybe I should just not include this, but the geometry approach is this. It's saying if I were to have a square, if my area was 9, what's the length of the sides?
3.
3. You give me 3 and 3, give me the 9. Or if the area was 4, what's going to be the length of my sides?
2.
Going to be 2 because 2 times 2 is 4. So if you want to think of it geometry-wise, you're talking, okay, what's a square whose area would give you like side lengths that don't have integers, or side lengths that don't have decimals. So it'd be all the squares with an area given by side lengths with no decimals. Okay, I digress. All right, is 225 a perfect square?
Yes.
Because
You can divide it by 5. And not have a decimal.
not divide by 5. If I were to take this, square root of 9 equals 3. Square root of 4 equals
2.
square root of 1 equals.
1.
So when we do square root of all those perfect squares, we get numbers that don't have a decimal, right?
Right.
So if I were to do square root of 225
15.
equals 15. So is 225 a perfect square?
Yes, because there's no decimal.
Yes. And if you wanted to, you could say because no decimal. So example 2, maybe pause a second. 1001.
Same, Sam.
222, is it a perfect square?
Yes, it is.
No. Because we could check it, if we do square root of 222,
There's a decimal.
we get
Some crazy number.
14.9 dot dot dot. As soon as you see the 0.9, you know it's not, so no. Because we have that 9 in there, we have a decimal. What was after the 9?
8996.
For 98996?
No, it's 8996.
Oh, 8, okay. Okay. So if I did the 0.9, I rounded correctly. So, all right, we still good with those?
Yes.
All right. Example 3. Does anyone remember the equation for the area of a square?
Length.
Length times
Width.
You could do length times width.
Oh, yeah.
But if we're talking a square, do you agree the length has to be the same length as the width?
Yep.
So usually for a square, they'll say area equals the side length squared. Fair enough?
Sure.
So if you start with that equation, what is the side length of a square with an area of 144? Do I put my 144 in here for S, or do I put it in for A?
A.
I put it in for A. And so I could put my 144 in here for A. So 144 equals S squared if I'm showing my work the way the math teacher here really loves it when people show their work. I don't want S squared, though. I want S. How would I get it just to be an S? Go for it, Sam. Perfect. That square root will cancel out the squared. If I square root my right side, I have to square root my left side. So the side length has to be 12. Yes?
144 equals.
So in other words, if I were to have a square, I'll try to draw a decent one here. If we know inside there that area equals 144, that's going to be a square with side lengths of 12. Fair enough?
I love the bottom of it.
So, too much sugar today. Then, so if we have that, what's the perimeter of that square? Perimeter is the, oh, go ahead, or just answer. Perfect. 48, exactly. Because you could do 12 plus 12 plus 12 plus 12. Because all those side lengths are 12. So if you want the distance around, it's 12 plus 12 plus 12 plus 12. Or
40.
some people, though, for a square, you could just say 12 times 4. For a rectangle, that wouldn't work. But squares, since they're all the same, you could just multiply by 4. So, nicely done.
Were we supposed to write that?
Totally up to you.
Oh.
We okay to jump to example 5? No questions so far? All right. Square root of 7. So example 5, square root of 7 is between what two integers? If you had to do this with a calculator, it's easy. Just punch it in, right? Square root of 7 equals, and then look at what two non-decimal numbers would be between. If you can't do that, if we go up to my perfect squares, or our perfect squares, I'll share, here, 1, 4, 9. Square root of 7 is going to, well, 7 is going to be between the 4 and the 9, agreed? And if square root of 4 equals 2, and square root of 9 equals 3, because my square root of 7 is going to be between those two, it'd have to be between, exactly. So square root of 4 gives me 2, square root of 9 gives me 3, square root of 7 is going to be right between them, it's going to be 2 point something. 2.64? Ooh, so 2.65.
What's example 3?
Okay, so example 5 then, it's going to be between 2 and 3. 2 and 3. And if you wanted to try to write a little bit more, you could say, if you're looking at perfect squares, square root of 4 is going to be 2. Square root of 9 is going to be 3. So because 7 falls between 4 and 9, square root of 7 is going to be somewhere in between 2 and 3. How are we doing? Example 5, we're okay on example 5? We're almost done. One more to go, then we're in the clear. So, all right, last thing. I have the square root of 81 over 25. Does the square root apply to the 81, the 25, or both?
Well, I have
Both, because they're both stuck inside there, right? And you can't do it if you have two things inside a radical with addition or subtraction. But I don't think that comes up too much now. But since the square root applies to both, could I convince you that I could say square root of 81 and square root of 25 like that? And square root of 81 is 9. Good, good, nice job. Because we're looking at what times itself. What squared is 81? 9 times 9 is 81. And square root of 25 is 5. So final answer could be 9 over 5. For this one, you could punch into a calculator and you would have gotten 1.8. But some of them are going to be something real ugly, like if we had a 49 in here, and I don't know what above it. So be able to do it that way as well. That's it for the section.
I just go to first.